So today we will be discussing spin-spin coupling. Okay. So for this discussion, I have preferred to take this particular example. So in this example, we can see that there are two carbons, and in these two carbons, there are two different hydrogens, and there are in total three hydrogens. However, and these three hydrogens are definitely in two different environments. Okay, because as you can see, it has been marked HA. These two hydrogens are bonded to this carbon, whereas HB is bonded to the other carbon, and HB is having a different environment because this HB is in a carbon which is bonded to two other Cl, whereas HA, two HA are bonded to a carbon which is bonded to one Cl. So therefore, it is having a different environment. First of all, if you like to judge on what will be the chemical shift or delta of these two, which will be higher, definitely this is much more deshielded and this is less deshielded. So therefore, if it is deshielded, means the electrons are much more being away from this particular nuclei, since it is bonded to 2Cl, and this 2Cl are having high electronegativity. So therefore, the electrons are pulled by these Cls and it is more deshielded, whereas these two nuclei are bonded to a carbon which is bonded to a single Cl, and hence the deshielding is much less. Delta value here is more, delta value here is less. But since these two are quite nearby, this nuclei will be having an influence on the other two nuclei, and accordingly there will be a change or a kind of signal splitting. Okay, this H will have two types of options. It can align with the magnetic moment of this HA, and it can even have a kind of opposite alignment with HA. So therefore, there are two kind of possibilities. Based on these two possibilities, therefore the peak of HA is will be splitting to a doublet. Okay, this will be splitting to a doublet. This being higher means it's aligning, and this being lower, it is being opposing. Okay, the magnetic moment of HB will be either aligning or it can be also opposing. So since there are two type of combination, hence there will be two doublets. Okay, and so you can see this one. So here, what is this? Here it is aligning, means it is aligning with the applied magnetic field, and it is deshielded, whereas it is opposing with the applied magnetic field and it is shielded, means it shields the HA. So therefore, if it is opposes and it is shielding, you know delta value is less. If it is aligning, it is deshielding the HA, and you know delta value will be more. So therefore, there are two types of possibilities, and hence there is a doublet. Whereas if you see this one, HA, two different magnetic moments are there of similar values, similar environment. This will also couple, or it will give a kind of rather the word will be perfect, like it will be coupling with the magnetic moment of HB in three different ways. How three different ways? So supposing this is having one alignment, and it will align with that of the applied magnetic field. This will oppose with the applied magnetic field. Similarly, another HA is also there. It can align, it can oppose. So it can be so that both are opposing, means both are having the same opposition. So if you see this particular arrangement, this is the applied magnetic field, two HA are there. So here it is one is opposing. Similarly, the other one is aligning, other one is opposing. So therefore, what you can see is that there is three different combination, and one is having a probability less, another is having probability less, whereas this one is having probability more, two combinations. So here what we have is, this is HA opposing, this is HA opposing, whereas these two are both are opposing. Okay, so here what we have is there is a triplet, there is a splitting triplet. So you know, if it is aligning, that the hydrogen, the nuclei will be deshielded. If it is opposing, the nuclei will be shielded. So therefore you have a kind of triplet. Okay, so this is where we have combinations and we can understand the environment. Supposing in this particular graph spectra, what you see is, here it is quadruplet, here it is singlet, here it is triplet. So triplet means definitely in its periphery, in its surrounding, what you have is two other nuclei of similar environment, and here it is not having any kind of nuclei which can split its signal, split its peak, and here it is having, and since it is quadruplet, definitely it is having three nuclei which will couple with it. So if you see the peak height intensity of this, it is highest, it is in between, and it is less. So if you count it, it will be it is 3, it is 2, it is 1. So that means what? This ratio is 3:2:1. So therefore it can have definitely maximum number of hydrogen present in a carbon is 3. So it is having 3, this is 2, and this is 1. So this one so since it has been splitted, its height has come down, but however, if you count the total area under this 3 peaks, what you will find, it is 3, it is also 3, and this is also having quadruplet. So therefore this, under this 4 peaks, if you count the area, it will come to 2. Okay, so it is 3, 3, 2. So if it is 3, 3, 2, so means what? It is this one is not having any nuclei to couple with it. Definitely it is having a gap with a kind of electronegative atoms, okay, which is not having any nuclei which is having a spin. Okay, so therefore it is, next one is HC, that is, it is having a splitting of 3, it is having a triplet. So definitely it is having environment where 2 nuclei are there. So definitely this can be the 2 nuclei, and this one is nearby this 3 hydrogens which is splitting each other, but it is not getting splitted because it is having a gap. So if you match with this diagram, we have 3 with a gap, and then this is 2 and this is 3. So this one is splitting this one is splitting this, whereas this one is HA is not being splitted. Similarly, this has been discussed. So we will go through this thing. So if you judge this one, what you have is these two are in the similar environment, and this is in another environment. This H, it is not bonded with with the methyl. It is bonded with an isopropyl. Okay, so therefore you have this one, a kind of similar type of equivalent hydrogen. This is equivalent. This is another. So this one is in this environment, so therefore it will be a doublet. Intensity will be very high, 6 hydrogens and a doublet. So next one, it will not have any splitting, it will be a singlet, and it will be having a high delta value because it is bonded to a carbon which is having electronegative atom. So therefore this particular carbon will have more deshielding. It will be pulled by this oxygen, and therefore this nuclei will be deshielded. So therefore it will be having high delta. And next is this is having H. So this H is having a kind of septate. Septate means 6 plus 1. There are 6 protons, and this will get split to a septate, and its delta value will be very high because it is also having the same kind of bonding. Means it is having a gap of 1, 2, 3, 4 bonds, and this is also having 1, 2, 3 and 4. So similar type of environment pooling will be there. It will be more deshielded since this pooling is only on one edge, whereas this pooling is being splitted by this will be distributed by 3 H. So this will get a little less delta, whereas this will get a little more delta than compared, because it will be more deshielded, it will be less deshielded. And here what you have 1, 2, 3, 4 and 5. Whenever there is a gap of 5 bonds, there is no deshielding. So there will be less, the delta will be, this H are more shielded. So therefore the delta will be quite less. Okay. So here come to this one. If you have this type of nuclei, so this is one environment, this is another environment. Then what will happen? These two are pooling the electronegativity. So this pooling is being distributed by 3H, whereas this is only taken by 1H. So there will be very high deshielding, and this is going to downfield, and therefore it is having very high delta value. What will be the splitting? Splitting will be 3 plus 1, it will be quadrate, and whereas this will be having comparatively lesser delta, and it will be a doublet. So come to this one. What we need to explain here is a kind of the term will be called anisotropy, that we will discuss later, because we have not yet reached this topic. We will do this topic later. Next one is here what you have is this is having CH3, this is CH2, and what will be the type? Here you have this is having singlet, very high delta value, very high deshielding is there. This is having a gap of 4 bonds. There will be deshielding, little more delta value, and it will be a quadrate. 3 plus 1 is 4. So the splitting will be, there will be 4 peaks. This is this one, and here it will be 2 plus 1, a triplet, but the deshielding 1, 2, 3, 4 and 5, there will be no deshielding, so delta value will be quite less. So multiplicity, if you have understood already, it is singlet, there is no neighbors. If it is a doublet, what is the ratio of the line? 1:1. It is having a neighbor of 1 nuclei. Okay, similarly, if it is a triplet, it is having a ratio 1:2:1, and it is having a neighbor, and the number of neighboring atoms is A2, and the 4 quadrate means you have a neighbor of 3, accordingly quintet, sextate, septate, octave, nonate. Okay. So another term is there, that is coupling. Coupling constant means what is the gap between two peaks, okay, which has been formed by splitting. 2 peaks, but initially it was 1 when the magnetic field, external magnetic field has been increased